Hi students, in this video we're going to cover the Boolean expressions and if statements mixed review. I've already worked this ahead of time and I'm just going to explain how I got what I wrote so that the video is slightly shorter. Okay, so for one, the tolerance is defined as the positive difference that's less than a particular value. So in this case, the tolerance is 0.001. And since tolerance doesn't take into account a negative difference, you need to return the positive difference. And the only way to do that is to use the absolute value. So the only difference between option E and option A is option A assumes that D1 is the larger value, which doesn't necessarily have to be true. If D2 was the larger value, A would return a negative value, and that wouldn't be less than 0.001. E doesn't care if D1 is smaller because of the absolute value. So E is the correct answer. Let's see, number 2. All right, so number 2 is one of these questions where you need to choose values that fit each condition. A is clearly not correct because if you ran this with A equals 4, B equals 5, and C equals 6, then the if statement won't execute because 4 is not more than 6. The else if statement won't execute because 5 isn't more than 6. So C, which is 6, will be returned. So A doesn't work because you can find something that actually produces the correct thing, which should be C in this case. B doesn't work because if C, it may not work correctly when C has the greatest value. Well, if you just use the numbers from A or B, that I have an option A or an option B, then C, which is the largest, should be returned. So in this case, C would still be returned. Option C is correct because if C, we've already seen that if C is the largest value, C is going to be returned. So the only thing you need to check is what happens if C is smaller than A and B when A and B are equal. So if A is 5 and B is 5, you're checking if 5 is greater than 5 and 5 is greater than 4. So remember, and statements are only true if both parts of the and statement are true. So 5 being greater than 5 isn't true. So the if statement doesn't work. But since A and B are the same thing, you're going to have 5 is greater than 5 again. But this time B is 5 and A is 5. And then 5 is greater than 4. So that's the 5 is greater than 4 part is going to be true. But 5 being greater than 5 is going to be false. So the if and the else if statement fail when A and B are the same. And so C is going to be falsely returned when A and B are the same and C is smaller. So the way to get around that would be that you just have greater than or equal to for one of those things. But anyway, C is correct because the method doesn't work when A and B are the same and C is smaller. If C is larger, it's always going to work. For number 3, this is just applying De Morgan's law. Remember, De Morgan's law turns ands into ors, and then it does the opposite of the individual parts of the the Boolean expression. So in this case, you would just, I don't like to say distribute, but effectively that's what we're doing. So you would have not A, the and turns into or, so we have not A or not B. And since we have this or C just hanging out, it's just not A or not B or C, which is going to make E the correct answer. For number 4, all right, so it would be advisable to turn the circled red statement into not X and not Y. And so again, and statements are only true, well, compound and statements are only true when each individual expression is true. So x and y is true when x and y are both true, and not x and not y are both true when not x and not y are true. So since x and not x are always going to have opposite values, either the circle blue statement or the circle red statement is always going to be false, because if x is true, not x is going to be false, which is going to make that and statement false. So for number 4, this is always going to be false. For number 5, we are effectively distributing y is greater than 10,000 or to the x is greater than 1,000 and x is less than 1,500. So that's just going to give us A as the correct answer. You preserve the and, so you're basically giving the x is greater than 1,000 and or y is greater than 10,000, and you're also giving x is less than 1,500, y is greater than 10,000. So again, A would be the correct answer. For number 6, we have another compound Boolean expression, and since it's an and statement, it's going to be true when x or y is true and when x is true. So if x is true, then you're going to have a true in an or statement and true. So that's always going to be true. If x is false, then because it's an and statement, the false part is going to nullify whatever happens right here. So this statement is always going to break down to be whatever x is. So that's why A is the correct answer. For number 7, we are applying De Morgan's law twice. So first you work with the inner not symbol. So we're going to have the opposite of A is not equal to B is going to be A equals B. And we still have B is greater than 7. And so now we work with the outer thing where we're going to have not A equals B and B is greater than 7. So the opposite of, so we, again, distribute. So we have not A equals B. And remember, the not turns ands into ors. So we have not A equals B or not B is greater than 7. So the opposite of A equaling B is that A does not equal B. And the opposite of B being greater than 7 is B is less than or equal to 7. So you should get B as the correct answer. For number 8, we have, I circled the two expressions that we have. We have a yellow statement and a blue statement, 1 and 2. Let's see. So we're trying to make C false. So for an or statement to be false, both of the individual expressions need to evaluate to be false. So one is only going to be false when A is false and B is false. When A is false or B is false. If A and B are both false, obviously it's false. But for an and statement to be false, just one of the statements has to be false. So the second statement, the blue statement, is going to be false when not A is false or when B is false. So since A and not A have opposite values, if A is true in the yellow statement, then not A is going to be false. So we're going to have a true statement, and whatever happens hinges upon what happens with B. If B is true, then we're going to have true and true, and that's going to negate what happens with the second statement. So this statement is only going to be false when B is false. So if it helps, let's assume that A is true. So if A is true, we're going to have true and whatever B is. So we're going to have true and whatever B is, and so since A is true, not A is going to be, scroll back, Mr. Martin. Where was I? I was right. Nope. Nope. Keep going. Oh, right here. So A, since A is true, not A is going to be false. And we're still waiting on what B could be. So again, for an or statement to be true, just one of the things has to be true. So if B is true, then this entire statement would be true, and it doesn't matter what happens over here. But if B is false, then this and statement is going to be false, and the other part is going to be false. And again, for an or statement to be false, both parts have to be false. So when B is false, the entire statement is false. Now you wonder, well, what if A is false? So if A is false, then B, if A is false, then not A is going to be true. And so again, what happens depends upon statement B. So if B is true, then this entire thing is going to be true. So B has to be false in order for the entire statement to be false. So for number 9, so when you have an if and an else statement, is the equivalent of having this or that. So the if statement is going to execute under a certain condition. The else is going to execute when the condition of the if statement isn't met. So in this case, to jump into the if statement, num has to be greater than 0. But then to execute the inner if statement of num being greater than or equal to 100, then num has to be greater than or equal to 100. So in order for B1 to remain true, num needs to be less than 100. But we already have the condition that num needs to be greater than 0. So in order for B2 to be true, if the first statement executes, num needs to be greater than 0 and less than 100. That's our first condition. So what happens if num is negative? Then you would need that. So in this case, in order for B1 to remain true, you need the opposite of num being greater than or equal to negative 100. That is the equivalent of num being less than negative 100. So if else statements are or statements, so we either have what happens in the first thing or what happens in the else statement. So we need num is greater than 0 and num is less than 100, or num is less than negative 100. And that would be option E. Now, again, this all hinges upon the fact that B1 is declared as true initially. So we need to keep B2 as true. So that means we need to do the opposites of these statements to make it true. For number 10, is this number 10? Yeah. So for number 10, one-way if statements are going to execute as long as the conditions are met. So if num boxes was 11, then this if statement triggers, that if statement triggers, and that if statement triggers. So what's going to happen is that total cost is just going to always be, in this case, total cost would be 55, because it's going to overwrite the first two statements. But what should happen is that num boxes, the total cost should be 11 times 150, but that doesn't happen because of these one-way if statements. 2 works because it has else, if, and else. So if num boxes is 11, then this statement triggers, but since that statement triggers, it stops the else, if, and the else from happening. For number 3, it's like number 1, but backwards. If you pick something like num boxes is 7, this statement is going to trigger, but the other 2 don't trigger. But you don't want the first statement. You only want the first thing to trigger if num boxes is between 1 and 5. So obviously this is going to work if you choose something between 1 and 5, but it's also going to execute if you have some value greater than 5. And that's not what you want to happen. So you would have to have, in order for 3 to work, you would need an and condition, non-boxes is greater than 0 and non-boxes is less than 5. And then this actually will work as intended, but as is, only 2 executes. Number 11 is, all right, so we have 3 different Boolean expressions to consider. So if num is greater than 0 is the same as telling you num is positive. But then inside that if statement, if the remainder of num when divided by 2 is equal to 0, that's the same as telling you that num is even. And so then the else is going to imply that num is not even, which means that num is odd. So the inner if statement executes when num is even and positive, you're going to print A. The else condition is going to print B, which implies that num is positive and odd. So that's going to make D the correct answer. Don't is easy to select C because you could forget that to even get inside the if statement, the value needs to be positive. So it's easy to choose C as the correct answer. For number 12, we have the static void message. And all right, so they tell us at the bottom that A is 5, B is 15, and C is 5. So the first if statement is going to execute because A equals 5. That inner if statement of B being, if B is less than 10, it doesn't execute because B is 15. So you don't print X. But this print statement of print Y is going to execute because A is less than 10. So we know we're going to print Y. And so now we're out of, because of this brace, we're out of that first if statement. And so now if C is less than 10, well, 5 is less than 10. So the next outer if statement executes. Then this if B is greater than 10, that if statement also executes because B is 15. And so since B is 15, we're going to print Y again. And because the if statement happened, this else statement that prints Z does not happen. So what is printed to the console is Y. This is an example of a question that if you didn't get, you could just go to Eclipse and literally type this method in and see what happens. But again, learning the process stuff without a compiler is helpful. Number 13, we haven't done for loops yet. I mistakenly included that question, so just totally ignore it. For number 14, so the if statement is only going to execute when X is less than 10 and Y is less than 0. So it doesn't execute because while 7 is less than 10, 3 is greater than 0. So the else statement triggers. But remember, X and Y are ints. So this is going to do integer division. It's going to do 7 divided by 3 and ignore the decimal part. So 7 divided by 3 is 2. So you're going to get value is 2. Don't get lost in processing the if statement and choose 2.333 repeating. That is a trick. Don't choose B. Number 15. So the word on this might confuse you. It's asking you if I give you three different numbers, you're not using them all at once. Like each of the numbers has to make each part of this if else chain happen. So another way to think about it is reword what these conditions are. If the remainder of a number when divided by 2 is equal to 0, that means that the number is even. So then we need a number that's even. We need another number that's more than 9, and then the else is going to be, well, what would happen if the if condition and the else if condition aren't met? It means that the number isn't even and the number is less than or equal to 9. So it's the opposite of both of those things. So the else condition with a chain of else, ifs, and ifs is just the opposite of the all those statements above it. So we need a number that is not even and the number is less than or equal to 9. So option C works because 8 will give you the even number, 11 would give you the number more than 9, and 9 would give you the number that is less than or equal to 9. If you chose option A, for instance, 8 would give you the number that is even. 9 would get so, but you have to again imagine that you're processing these one by one. So if you choose 8, then the if condition is going to trigger. If you choose 9, the else condition is going to trigger. And if you choose 12, the if condition triggers again. For option B, if you choose 7, 9, and 11, then the else condition is going to trigger. And then if you choose 9, the else condition is going to trigger. And if you choose 11, the else if condition is going to trigger. But again, for 8, the if condition would happen. For 9, the else condition would happen. And for 11, the else if condition would happen. And for number 16, I think it's the last one. It's a method that has to return a string, and that's going to be important. And all right. So for the first thing is option 1 works because it goes through. It's an if, else, if, and else condition. So like if we choose if the density is like 1,000, the if condition does not execute. The else if condition would execute and set category equal to suburban. And then at the very end of this, we return whatever category is, or cat as they call it. So number 1 works. Number 2 does not work because it's a one-way if statement that doesn't have a return inside the if condition. So as long as, so if we choose a population of 2,700, it's going to set category equal to if the density was like 5,000, then category would be urban. But then because of if density was 5,000, because 5,000 is also greater than 999, cat will equal suburban. And then at the very end, it's going to set cat equal to rural. So all 3 of those categories are going to change 3 times and then return cat. And that's not what you want to happen. So 2 does not work. 3 does work, even though it's just like 2. The difference is the return is inside the if statement. And when you return from a method, the method ends right there. It doesn't if we use a density of 5,000, this first if condition is going to execute and it's going to return urban, and you never get to the 999, which is why you should not include return statements in if statements, because sometimes you might want to reach other code, and the if statement would, if the return's inside the if statement, it stops that from happening. So 3 works because, again, the return exits the method. So the option here should be 1 and 3. All right, so that concludes this video explanation of this mixed reviews. If you have questions, I will see you all in class.